Hello students, welcome you all for the lecture session on pumps and actuator. In today's class, we are discussing about the hydraulic motor, types of hydraulic motor, construction and their working. So first we need to know what is the definition of hydraulic motor. So hydraulic motors are the mechanical device which converts the hydraulic energy into mechanical energy in the form of continuous rotation as well as the torque. And the construction of the hydraulic motor resembles to the construction of the hydraulic pump. And in case of the hydraulic motor, the pressure of the oil pushes the freely moving element, thereby developing the continuous rotation as well as the torque. And the classification of the hydraulic motor, it's very simple. Based on the nature of the freely moving element, it is categorized into 4 types. The one it is called gear motor, vane motor, piston motor and a screw motor. And based on the speed and the torque, it is categorized into 2 types. The one it is called low speed and high torque, another one it is called high speed and low torque. And third one it is called based on the displacement. It is again categorized into 2 types. The one it is called fixed displacement. In the fixed displacement, again it is categorized into gear motor, vane motor and a piston motor. And in the variable displacement, it is categorized into only one part, that is called as the piston motor. Okay. So in the previous class, the Professor Ramanand has completed the gear motor and the different types of the gear motor. So in today's class, I am discussing about the vane motor. So vane motor, which develops the torque at its output shaft by allowing the highly pressurized fluid enters into the radial vane, and these radial vanes are going to slide in and out of the rotor slot, and this rotor slot which is plied to the driving shaft. So this is called as the vane motor. I repeat, what is meant by the vane motor. So vane motor is a positive displacement motor which develops the torque at its output shaft by allowing the highly pressurized fluid enters into the radial vane. These radial vanes are slides in and out of the rotor slot which is plied to the driving shaft. So this is regarding to the definition of the vane motor. Then what are the constructions of the vane motor? The vane motor, it is mainly consists of the rotor, radial vanes, camring, inlet and outlet port as well as the casing. And very important one, it is called, in case of the vane motor, here the center line of the rotor and the center line of the camring are not the same, hence eccentricity is going to achieve in case of the vane motor. Then as well as here the radial vanes are slides in and out of the rotor slot, and that will be completely contact with the camring during its rotation. So this is the construction of the vane motor. I repeat, what is the construction of the vane motor? It mainly consists of the rotor, rotor slots, radial vane, camring, casing, inlet and outlet port. Then very important one, it is called here center line of the rotor and center line of the camring are not the same, hence eccentricity is going to achieve. Then very important one, it is called the radial vanes are always contact with the camring during its rotation. Next, working. When the pressurized oil enters through the inlet port and then it enters into the small pressure area of the radial vane. Hence, when small pressure area of the radial vane it contacts with the highly pressurized oil, hence this will going to causes the rotation of the rotor as well as the rotation of the driving shaft. Okay, so because of the eccentricity between the camring as well as the rotor, then larger surface area is going to created during its rotation, hence higher force and higher torque will going to develop during its rotation. So this is called as the working of the vane motor. Okay, so I repeat, when highly pressurized oil enters through the inlet and then it enters into the radial vane, so because of the small pressure area, so this rotor is going to rotate. When the rotor is going to rotate, so because of the eccentricity between the rotor as well as the camring, then high surface area is going to develop. So because of the high surface area, then higher force and higher torque will go into develop. So this is called as the vane motor. And this vane motor, it is also called as unbalanced vane motor. Why it is called as unbalanced vane motor? That is very much important. So in case of the unbalanced vane motor, two pressure are going to exist. So the one it is called the system pressure, the another one it is called it as the outlet pressure. System pressure it is called PS and outlet pressure it is called PO. And very important one it is called here, system pressure PS is always greater than the outlet pressure. So because of this system pressure, then the side load is going to exist, side load are going to exist on this motor shaft. Okay, so because of the system pressure is greater than the outlet pressure, then side load is going to exist on the motor shaft, and these side loads it is mainly because of the only one inlet and one outlet ports. Okay, so here system pressure is greater than the outlet pressure, because of that side load is going to exist on the motor shaft. So because of that, then the bearings are going to experiences the unbalanced forces. So in order to avoid the unbalanced forces, we are moving on to the balanced vane motor. Okay, so what happens in case of the unbalanced vane motor? Here two pressures are going to exist. The one it is called system pressure, another it is called as the outlet pressure. And here, so because of the system pressure is always greater than the outlet pressure, side load is going to exert on the motor shaft. Okay, so whenever side loads are going to develop mainly because of the one inlet port and one outlet port, so this will going to cause us the unbalanced forces on the bearing, and this will going to reduce us the efficiency of the vane motor. So then in order to eliminate this problem, we are moving on to the balanced vane motor. So that means the unbalanced side load and the bearing load on the vane motor, it is going to eliminate or prevented with the help of by replacing the circular housing with the help of the elliptical housing. I repeat, what happens in case of the balanced vane motor? Observe in the construction here, we are replacing the elliptical housing instead of circular housing in case of the balanced vane motor. That means in case of the unbalanced vane motor, the side load can be eliminated with the help of the elliptical housing instead of the circular housing. So that is main thing regarding to the balanced vane motor. As well as in case of the balanced vane motor, it mainly consists of two inlet and two outlet ports. Okay, so balanced vane motor, it mainly consists of the two inlet and two outlet ports, and these two inlet and two outlet ports are diametrically opposite to each other, as well as here the center line of the rotor as well as the center line of the elliptical housing are in the same line. Okay, so what is the main advantage in case of the balanced vane motor? So because of the two pressure ports are provided at the diametrically opposite to each other, therefore whatever the side loads are going to develop on the motor shaft as well as at the bearing, it will going to nullify. That is the main advantage in case of the balanced vane motor. Okay, so now observe what are the construction. So the construction is very simple. It is mainly consists of the rotor, radial vane, elliptical housing, two inlet and two outlet ports. Okay, as well as it also contains the driving shaft. So then it is very important one, it is called here the center line of the axis, center line of the rotor and the center line of the elliptical housing are in the same. That means there is no eccentricity is going to achieve in case of the balanced vane motor. So then very simple, when highly pressurized oil enters through the inlet, then it is forces on the radial vane. So due to the when high pressure oil exerts the force on the radial vane, this radial vane is going to pushes the vane towards the driving shaft, and this will going to causes the rotation of the driving shaft as well as the torque will going to develop. Then highly pressurized oil which will going to coming out through the outlet port. So this is the main advantage in case of the balanced vane motor. So working is very simple. When highly pressurized oil through the inlet, it is enters into the radial vane, and when it exerts the force on the radial vane, and this will causes the rotation of the rotor, and the driving shaft is also going to rotate, hence output shaft will going to develop the power, and highly pressurized oil will coming out through the outlet. and a very important one is of the elliptical housing as well as the axis of the rotors are same, hence side load will going to nullify, as well as very important thing it will going to provide the better service life compared to the unbalanced vane motor. That's why we are going to prepare the balanced vane motor compared to the unbalanced vane motor. So next very important one, it is called, what is mean by the piston motor. So piston motor, it is also called it as the one of the type of the hydraulic motor. So what happens in case of the piston motor? So piston motors are, it is also called as a linear hydraulic motor, in which the pressure of the oil causes the to and fro motion of the piston, which in turn causes the rotation of the piston shoe, then swash plate. It will going to develop the output. So that is regarding to the piston motor. So then what are the classification of the piston motor? So piston motors are basically classified into two types. The one, it is called axial piston motor. Another one, it is called radial piston motor. So in the axial piston motor, it is again classified into inline axial piston motor. So in the inline axial piston motor, again fixed displacement type. Okay, fixed displacement type. In the fixed displacement type, two type, swash plate design and oval plate design. Okay, then variable displacement type, and another one, inline axial piston with bent axis. Okay, so this is the regarding to the classification of the piston motor. So I already told, so in case of the piston motor, it's also called it as the hydraulic linear motor. Here the pressure of the oil causes the to and fro motion of the piston inside the cylinder block, that will causes the rotation of the cylinder block as well as the rotation of the output shaft, that will going to develop the power. And here inline axial piston motor, here very simple, here piston is going to reciprocate inside the cylinder block with the parallel to the axis of the cylinder block. Okay, but in case of the bent axis, cylinder block is located at an angle, and in case of the radial piston motor, here the piston is going to reciprocate radially or perpendicular to the axis of the output shaft. Then it is called as the radial piston motor. So construction and working we are going to see further. So the next topic, it is called as piston motors. So in case of the piston motor, we are already discussed the main classification, it is called as the axial piston motor as well as the radial piston motor. So what is meant by the axial piston motor? So axial piston motor means it is nothing but here the piston is going to reciprocate inside the cylinder block at the axis parallel to the output driving shaft, then it is called as the axial piston motor. And what about in case of the radial piston motor? In case of the radial piston motor, your piston is going to reciprocate radially or perpendicular to the axis of the driving shaft, then it is called as the radial piston motor. So in case of the axial piston motor, it is again categorized into two types. The one, it is called fixed displacement. So in the fixed displacement itself, it is called as the two types. The one, it is called swash plate design, other one it is called as the oval plate design. So what happens in case of the swash plate design? In case of the swash plate design, here the cylinder it is connected to the fixed swash plate. Okay, that means here the piston is going to reciprocate inside the cylinder block, and the piston it is connected to the piston shoe, and the piston shoe is connected to the shoe plate, and the shoe plate it is connected to the fixed swash plate, then it is called as fixed swash plate design. What about in case of the oval plate? In case of the oval plate, the swash plate itself it is called as the oval plate, but oval plate it is connected to the output driving shaft, and here the piston, cylinder block and the piston shoe all are called as the fixed, and it will not going to rotate in case of the oval plate design. But in case of the swash plate design, cylinder block, piston, piston shoe and the shoe plate all are going to rotate against the fixed swash plate. So that's why it is called it as the fixed swash plate design. Okay. So first we need to understand what is the inline axial piston motor of the fixed displacement type. Okay. So observe here, the construction it is mainly consists of cylinder block, piston, piston shoe, shoe plate, swash plate as well as the output shaft. Very important thing, it is called your cylinder block, piston, piston shoe and a shoe plate all are going to rotate against the fixed swash plate and the output shaft. So that is the first part in case of the construction. In the second part, very important one, it is called your cylinder block, it is connected to the output shaft as well as here the piston is going to reciprocate in and out of the cylinder block at the axis parallel to the driving shaft. So this is very much important in case of the fixed swash plate design. I repeat, in case of this fixed swash plate design, here cylinder block it is connected to the output shaft and the piston is going to reciprocate in and out of the cylinder block at the axis parallel to the driving shaft. So this is regarding to the second part in the construction of the fixed swash plate design. Next very important one, it is called here this piston shoe and the spring holds this piston against the fixed swash plate. I repeat, here piston shoe and the spring it holds the piston against the fixed swash plate and very important one, it is called here swash plate, it is located at an angle to the piston. Okay. So this is regarding to the construction. I repeat, so observe here the main parts are cylinder block, piston, piston shoe, shoe plate, swash plate and output shaft, and cylinder block, piston, piston shoe and a shoe plate all are going to rotate against the fixed swash plate, and then here cylinder block it is connected to the output shaft and the piston is going to reciprocate in and out of the cylinder block at the axis parallel to the output shaft. Then very important one, piston shoe it holds the piston against the swash plate and the swash plate it is located at an angle to the piston. Then working. So working is very simple. When highly pressurized oil enters into the inlet through the kidney shaped opening, and when this highly pressurized oil enters through the inlet to the kidney shaped opening, what happens? So it will going to exert the pressure on the 3 to 4 piston located around the cylinder block. Okay. So at the opening side, when the pressure on the opening side is going to end, this will going to exert the pressure on the piston. Whenever this will going to exert the pressure on the piston, what happens? So this piston is going to move outwards and towards the swash plate. When this piston move towards the swash plate, then this will causes the rotation of the cylinder block as well as the output shaft. Hence the torque will going to develop in case of the fixed swash plate design. I repeat, as the pressurized oil enters into the opening of the inlet, then this will going to exert the pressure on the 3 to 4 piston provided and situated at the cylinder opening. Okay. So as the pressure is going to exerted on the piston is going to move outwards and this will going to exert the pressure on the swash plate. So whenever we exert the pressure on the swash plate, then this output shaft is going to rotate, hence it will going to develop the torque. So this is regarding to the swash plate design. Observe here, so this is the construction of the cylinder block. Here cylinder bores are provided and all the pistons are going to reciprocate in and out of the cylinder block with the help of the piston shoe, and this will call it as the shoe plate, and this shoe plate it is connected to the swash plate. So this is the construction of the inline axial piston motor of the fixed plate design, especially for fixed swash plate design. Okay. So oval plate design, it is very simple. In case of the oval plate design, here the oval plate is connected to the driving shaft, but this cylinder block, piston shoe and the shoe plate all are going to fixed, but the oval plate is going to rotated with the help of the output shaft. That is the going to difference between the swash plate design and oval plate design. Then second one, inline axial piston motor with a variable displacement type. So I already told, in case of the variable displacement type, that means here the swash plate it is not fixed. Observe here swash plate it is going to fixed, but here the swash plate it is not going to fix. So why we need to use the variable displacement type, or how to achieve the variable displacement type? It is very important. So the variable displacement type, it is nothing but the function of varying the or varying the offset angle or varying the swash plate angle. That is very much important. Okay, so how we going to vary the offset angle or swash plate angle? Because here swash plate, in case of the variable displacement type, it is connected to the swinging yoke, okay, or it is also called as the swinging yoke mechanism. However, by varying the swash plate angle with the help of the anvil or a lever or a servo controller, we can achieve the different angles. So by varying the different angle, what happens? That is very much important. So our main intentions in case of the hydraulic motor, we need to achieve the high speed low torque or low speed high torque. So that cases we are going to achieve in case of the variable displacement type inline axial piston motor. So observe here, in case of the increased swash plate angle, the displacement of the piston motor with the swash plate is going to increases. Okay, so by increasing the swash plate angle, the displacement of the piston motor with the swash plate is going to increase. This will going to increase the torque, but this will going to reduce the speed of the motor. That is the very much important thing in case of the increased swash plate angle. Okay, I repeat, in case of the increased swash plate angle, as the swash plate angle is increases, the displacement of the piston motor is going to increases. By increasing the displacement, then the torque will going to increases, but the speed of the hydraulic motor is going to decreases. So that is the very much important thing. Next, second one, at the converse case, decreased swash plate angle. As the swash plate angle decreases, then displacement of the piston motor is going to decreases. By decreasing the displacement motor, torque is going to decreases and speed of the hydraulic motor is going to increases. So that is the second case. And the next one, it is called zero swash plate angle. In case of the zero swash plate angle, so that means there is no speed and torque can be achieved. But so minimum angle should be provided in order to operate the hydraulic motor within the operating limits. So that is regarding to the three cases regarding the variable displacement type of inline axial piston motor. Okay, so first of all, why we need to use the variable displacement type? Because it happens only with the help of the variable plate design. Okay, so that means by varying the swash plate angle or offset angle, the displacement of the piston motor can be obtained. So how displacement of the piston motor can be achieved? By changing the offset angle or swash plate angle. So this is regarding to the inline axial piston motor with a variable displacement type. Then axial piston motor with the bent axis. So this is a different kind of construction. So observe here. So what are the important parts of the axial piston motor? It remains the same. It mainly consists of the cylinder block, piston rod, then drive shaft flange, ball and a socket joint, and the driving shaft. And here very much important thing, it is called, in case of the inline axial piston motor, observe here the output of the driving shaft and the swash plate or the output of the driving shaft and the cylinder block are collinear. But in case of the axial piston motor bent axis, here the axis of the cylinder block, it does not collinear with the driving shaft. That means here the center line of the cylinder block, it is located at an angle to the driving shaft. Okay, so observe here. So next part, it is called, here the piston rods are connected to the drive shaft flange with the help of the ball and a socket joint. And piston rods are going to slide in and out of the cylinder block as the length between the drive shaft flange and the cylinder block will going to varies. So next, in the working case, as the highly pressurized fluid, it enters into the cylinder block, what happens? When highly pressurized fluid enters into the inlet of the cylinder block, then this will going to pushes the piston outward. Whenever it pushes the piston outward, then entire cylinder block is going to rotate. So whenever cylinder block is going to rotate, driving shaft is also going to rotate. Hence output is going to achieve in case of the axial piston motor bent axis case. Okay, so I repeat. So what are the construction? It consists of the cylinder block, piston rod, drive shaft flange, and the drive shaft. And here very important thing, it is called, here piston, it is connected to the drive shaft flange with the help of the piston rod with the help of ball and a socket joint. And very much important thing, it is called, here axis of this driving shaft and axis of the cylinder block, it is located at an angle. When highly pressurized fluid, it enters into the cylinder block, then this will going to pushes the piston and this will going to causes the rotation of the cylinder block as well as the rotation of the driving shaft. So that will going to develop the power. Last one, the radial piston motor. So what is the working of the radial piston motor and what will be the construction, very important. So I already told, in case of the axial piston motor, here piston is going to reciprocate in and out at the axis parallel to the axis of the driving shaft. But in case of the radial piston motor, piston is going to reciprocate radially or perpendicular to the axis of the output shaft. So this is called it as the radial piston motor. So what are the parts? So parts are, again, it contains the cylinder block, rotor, then the rotor having the radial slot through which piston is going to reciprocate in and out. Then the working is very simple. When highly pressurized fluid enters into the inlet and then it exerts the force on the piston, and this will going to pushes the piston outwards. Whenever the piston pushes outwards, whatever the cylinder block containing the piston, it is going to rotate. Once the cylinder block is going to rotate, then rotor is connected to the driving shaft and the cylinder block is also going to rotate. Hence output shaft is going to rotate, then torque will be going to develop. I repeat, when highly pressurized fluid enters into the inlet and this exerts the force on the piston, and that will going to pushes the piston outwards. Hence the cylinder block connected to the piston is also going to rotate. Once the cylinder block rotates, then rotor is also going to rotate and output shaft is going to rotate and torque will be going to develop. And again, in case of the radial piston type motor also, we can see both the fixed displacement and the radial displacement. How to achieve the variable displacement? So variable displacement can be achieved by varying the length of the piston. So how to varying the length of the piston? By varying the length of the piston with the help of the increasing the eccentricity between the center line of the rotor as well as the center line of the cylinder block. Okay. So in this condition also we can achieve the variable displacement type of radial piston motor. So this is regarding to the hydraulic motor. So in the hydraulic motor we are mainly discussed about what are the gear motor and what are the types of gear motor, and next what are the vane motor. So in case of the vane motor we have seen unbalanced vane motor as well as the balanced vane motor, and in case of the piston motor, so there are three types. One is called inline axial piston motor. So inline axial piston motor, that is called fixed displacement type. So in the fixed displacement type, two types, swash plate design and oval plate design. So next it is called variable displacement type. So here by varying the swash plate angle, so what will be the changes in torque and the speed we can see by variable displacement type. Then axial piston motor with the help of the bent axis design. So that means here the axis of the driving shaft and axis of the cylinder blocks are not the same. We are located at the angle, and how the output shaft we can obtain, that can be seen in the axial piston motor with the bent axis design. The last one, it is called radial piston motor. So in the radial piston motor also we can achieve the fixed displacement as well as the variable displacement by changing the eccentricity between the cylinder block and the rotor. We can also see the variable displacement. Thank you.